Hello everyone, how are you? Hope you are fine. Welcome to our presentation in Enterprise Network Management. I'm a student from Team University pursuing a bachelor's degree in Information Technology. My name is Dumba Ashraf and I'll be making this presentation with a colleague called Kwejuka Jonan. In this presentation, we shall have 4 questions to answer. And question number 1 will look at internet protocols, how internet protocols work, versions of IP, the differences between the internet protocol versions. Question 2 will look at what is quality of service, why do we need quality of service and its purpose, quality of service mechanisms with brief examples of how they will be used. Question 3 will look at security controls, examples of security control concepts with their functions and drawbacks. And question 4 will look at cloud computing, as a service, and it also look at cloud troubleshooting. With that brief introduction, let's start our presentation. Question 1. Question 1 is as an expert in enterprise network management, compare IPv4 and IPv6 addressing at a high level, highlighting the major advantages of IPv6 for enterprise networks. Now, this question before we answer the question, I would like us to first know what is IP, or what is Internet Protocol. The Internet Protocol is a set of rules that govern how data is sent and received over a network, such as the Internet. We know the Internet is a certain type of a network. So the IP's main job is to route packets of data from a source device to a destination device, relying on IP addresses to know where to send the data. IP is considered the backbone of modern networking. Not to go deeply into the previous methods of networking, networking used to be more of a wire thing. It used to be more of hardware, but as time has gone by, networking has now been integrated with hardware and software. That means it has tangible and intangible aspects to it. So IP is considered the backbone of modern networking. That is a mix of software and hardware. It could be wireless. You could have a wireless network, but you could also have a mix of two. To continue, let me show you a diagram of how IP works. It's a simple diagram. As you can see, we start with packet creation, then it goes to addressing. After the packet is created, they address it, they route it through the router, and then reassembly after it has reached you in the way it was, or in the way it was sent. Why reassembly? You could find it could be disintegrated for several reasons, but once it arrives on your laptop, it's reassembled in the same packet as it was sent. It could be a data packet, it could be an information packet, but yes, it's reassembled. More about IP. IP is a connectionless protocol, meaning that each packet is treated independently. This best effort delivery method is very efficient for sending data quickly, but it does not guarantee that packets will arrive intact in the correct order or even at all. So this is trying to mean that IP alone isn't responsible for the best effort delivery. So that means there are certain parts of IP, or there is another protocol that is added to IP, which makes it now efficient in making sure the packets arrive in the correct order and they even arrive to their destination. Now this protocol I'm talking about is called the Transmission Control Protocol, or TCP. Now this TCP works alongside IP to ensure reliable data delivery. It also establishes a connection, orders for packets, requests for retransmission of any lost packets or corrupted packets. This is why the Internet Protocol Suite is often called the TCP/IP. Now let's go to versions of IP. Version number 1, we have IPv4. IPv4 is the older version, and it uses a 32-bit address system or mechanism, which provides approximately 4.3 billion unique addresses. An IPv4 address is typically represented in dotted decimal notation, such as 192.168.1.1. We could add a 0, you could add a 1. This not to go deeply, I have to stay on course, but these dotted decimal notations or the IPv4 addresses are classified in classes. There is class A, B, C, D. We shall have to make another video about that because it's also another topic of its own. The rapid growth of internet led to the depletion of the available IPv4 addresses. This means that this limited number of 4.3 billion has almost been exhausted due to the high growing internet use. Yes, addresses are being created every day, are being needed every day, so now they are about to be exhausted. But not to worry, a solution was formed, and that was the formation of IPv6. This newer version was developed to address the exhaustion of IPv4 addresses. It uses a 128-bit address mechanism, creating a virtually unlimited number of unique addresses. IPv6 also offers improved security features and more efficient routing. Yes, since IPv6 offers more unique addresses, by unique, addresses have to be unique, because if we all had the same addresses, that means a lot of data would be lost. So this is self-explanatory. But now we are going to continue to the differences between IPv4 and IPv6. Let's continue. Yes, as an expert in enterprise network management, the shift from IPv4 to IPv6 is a necessary evolution, not just a technical upgrade. The fundamental limitation of IPv4's infinite 32-bit address space has been evident for years. In contrast, IPv6 offers a permanent solution with a 128-bit address space and delivers substantial architectural advantages for enterprise networks. Yes, we're going to look at the differences between IPv4 and IPv6. The first difference is IPv4 has a 32-bit address format, approximately 4.3 billion unique addresses, a quantity now exhausted globally. IPv4 uses RFC 1918 private address ranges, e.g. 10.0.0.0/8, with a NAT to conserve public addresses. When we look at IPv6 has a 128-bit address format, 8 groups of hexadecimal digits separated by colons, e.g. 2001 colon 0db8 colon 85a3 double colons 8a2e colon 0370 colon 7334 colon. It also uses unique local addresses that are available for private network use with vast public address eliminated the general need for NAT. We see the acronym NAT appearing both in IPv4 and IPv6. Now one asks themselves, what is NAT? NAT is network address translation. Now this works in IPv4 as a technique used to enable different devices use the same IP to communicate to the internet. Now, since in IPv6 there is what we call a unique local address mechanism or a unique local address technique that can be used. This enables devices on a private network to use different addresses. Remember, it has a vast public address space, and this can eliminate the use of a network allocation translation technique. This is a very big step in networking, since it's even more secure and it's more efficient. To continue with our differences, we have a variable length header 20 to 6 bytes, including a checksum that routers must recalculate at each hop. There is a static assignment or managed by dynamic host configuration protocol, and we have in the IPv6 side a simplified fixed length header of 40 bytes with no checksum, which speeds up packet processing on routers. Features stateless address auto configuration slack for simplified setup, allowing devices to self-configure without a DHCP sub. Yes. We are going to look at the advantages of IPv4-6 for enterprise networks, for modern enterprise networks. And our first advantage is unlimited scalability and growth. The sheer size of IPv6 addresses space future proofs and on an enterprise network. It provides a unique globally routable address for every device, including PCs, servers, mobile devices, and multitude of sensors and actuators in an Internet of Things deployment. Our second advantage, it is a simplified network. It makes network management very simple because it is designed with network management in mind, offering several features to reduce complexity and overhead. Our third point, it enables enhanced security. IPv6 was developed with security as a core component, unlike IPv4, which had security protocols later. Number 4, improved network performance. Several architecture improvements in IPv4-6 lead to better performance compared to IPv4, sorry. It has better support for emerging technologies. What does this mean? IPv6 is essential for technologies that require a large number of public routable IP addresses. It includes cloud computing, 5G networks, and a proliferation of Internet of Things. Adopting IPv6 is a crucial step to ensure the enterprise network can evolve to support future demands. That was question 1. I noticed maybe there could be questions coming from words like the terms we used earlier on as hop, as checksum, but we promise to make another video due to demand that will address to look at IPv4 in detail and also look at IPv6 in detail. But as for now, we are going to be guided by the questions, our map that we had earlier on, so that we finish this presentation in time. Be free to check out our YouTube page for more videos concerning this. As of record, I promised to make one of IPv4 and IPv6. Yes, our second question is going to look at quality of service. And the question is as follows. Question 2. Explain the purpose of quality of service course in an enterprise network and name the course mechanisms with a brief example of how they'll be used. Yes, now I for one, I love quality of service. Why? Quality of service isn't something you can miss out when you are into network management, because some of us that use let's say WhatsApp calls, those that use those gamers, yeah, I myself am a gamer. I need to know that when I'm playing the game online, for example, everything has to be set. When I'm communicating with the people, I have to receive real-time information. Take an example, people who use WhatsApp. Imagine if you would send a message now and it arrives an hour later. So quality of service in networking is a set of technologies and mechanisms used to manage network traffic by prioritizing certain applications, users, or data flows over others to ensure a predictable and guaranteed level of performance. Usually quality of service, just to mention, it is used for voice over IP. Voice over is when something is happening. Let's say you watch people streaming while playing games. Yes, that voice, the audio is like it's happening. You might even see a small video like what's happening right now. This is like a good example of voiceover. You see me, and again you see the presentation. There is video conferencing. Since 2020, the COVID period, we have experienced a high usage in video conferencing with apps like Zoom, Google Meet. There are very many. We have really experienced a boom in the use of video conferencing, and this is very possible because of quality of service, that the quality of service mechanisms. Then we have online gaming. Uh, we have online gaming. Yeah, we know what online gaming is. Now, still you ask, why do we need quality of service, and why is it, what is its purpose? Yes, that's a valid question. Network data is treated on a best effort basis, where all packets compete equally for available bandwidth. So without cost, this can lead to packet loss during network congestion, increased latency, latency is delay, and jitter, variation in delay, with several which severely can cause if, let's say, if I was on WhatsApp and I sent a message that arrived tomorrow, yet I sent it today, that is going to degrade the quality of real-time communication. Yes, it's going to degrade the quality of real-time information. So if there is increased latency or delay and jitter, because it could be delaying every after 2 minutes, but imagine today it takes 2, tomorrow it takes 3, in an hour's time it takes 40 minutes, that's going to really degrade the quality of real-time communication, which is very essential in day-to-day businesses and other applications. There will be poor user experience for critical business applications. The need for expensive bandwidth upgrades when traffic is poorly managed. Now, CORS, that means provides network administrators with tools to manage the issue, because these issues are very, very, very crucial. But now, what does CORS do? Why is it important? Why do we need it? It provides network administrators, those people at the top, making sure me and you are enjoying the resources on the network, with tools to manage these issues by maybe prioritizing critical applications to ensure they have necessary resources. As you may see, another example I can show you here is most of us, when we're using our phones to do, let's say, video games, you're reading a book, you're watching YouTube, you have seen this, you have experienced this, that when someone calls, that call notification, okay, the call takes over the screen, or it takes a part of the screen. What does this mean? With such a mechanism, the phone or the operating system knows that a phone call needs first priority, unless you don't like to pick it up, or unless you don't want to pick it up. So even when you're doing anything else that is very important too, this phone will first send the phone call. Yes, so quality of service is also used in allocating bandwidth efficiently to avoid congestion, and it's also used to improve user experience for time-sensitive services. Continuation. Quality of service provides network administration with tools. Yes, I'm going to explain all those points in details. Prioritizing critical applications to ensure they have necessary resources. This helps network administrators prioritize critical applications by providing specific tools and mechanisms to identify, manage, control how different types of network traffic are handled, especially during network congestion. Allocating bandwidth. This generally means it helps network administrators allocate bandwidth by enabling them to define, manage, and enforce how much of the resources different applications, services, and users can consume. This is crucial for optimizing network performance, especially during time of congestions without necessarily needing expensive bandwidth upgrades. Our third point of view of improving user experience, CORS helps network administrators significantly improve the end user experience by ensuring critical and time-sensitive applications that perform reliably and consistently. Uh, we are going to look at some of the mechanisms with a little brief explanation of the, or examples of how they'll be used. The first mechanism we're going to look at is classification and marking. What is classification and marking? Classification, as you can see, requires you to identify and tag packets with a priority identifier. Now that is maybe a call, they have a priority identifier that when a call comes, it just knows this is a very, very, very important important thing to follow, or an important task to follow as they enter the network. An example of this, a network edge router inspects all incoming data and marks voice over IP packets with a platinum DHCP protocol value, while email packets receive a bronze value. So as you can see, phone calls or calls are platinum, emails are bronze. Yes. We our second sorry for the word it's an example. Sorry for that. Our second mechanism is queuing and scheduling, placing packets in two different priority queues during congestion and determining the order in which they are transmitted. Yes, queuing, lining, scheduling come at this time. As you can see, I have a schedule. When an internet link is saturated, the network uses low latency queuing. This latency low delay queuing to ensure that voice packets are always sent fast before data packets from a large file transfer are processed. That is very flat. As you can see, you can understand it easily. Traffic shaping, buffering excess packets to smooth out data flow and send it at a controlled, consistent rate, preventing sudden bursts of overwhelming the network from overwhelming the network. Yes, an example in this: traffic shaping, buffering excess packets to smooth out data flow and send it at a controlled, consistent rate, preventing sudden bursts from overwhelming the network. This is also going to stop jitter. Jitter is when the delays are inconsistent. It comes after 2 minutes, then after some time it comes after 4, after some time it comes after 30 minutes. So once this mechanism is put in place, the enterprise limits the speed of data backup transfers to a remote data center during business hours, because during business hours employees or people that use the system are using it for uh, they are fetching data, they are fetching information. Now if the enterprise puts data backup as a priority, that means people using this same data center on business hours to get information they need right now will be delayed. So that means holding excess packets in a buffer to ensure ample bandwidth for real-time operations. Remember, these servers do a lot of things at the same time, but if there was no mechanism to show that this is a priority, this is important, because all those things have to be done. Yes, they have to be done and in time. But then the only problem is when it comes to the only problem comes when you don't prioritize what's important. That means you're going to fail the operation. There is traffic policing, enforcing a maximum bandwidth limit by dropping packets that exceed a predefined rate. An example policy is set to drop any peer-to-peer file sharing traffic that exceeds 2 Mbps to ensure it doesn't consume all available bandwidth. There is congestion avoidance, proactively monitoring network usage and selectively dropping low priority packets before congestion becomes severe to protect total network collapse. An example: a network uses weighted randomly early detection to drop some lower priority packets when a link reaches 75% capacity, signaling to senders to slow down before the link is 100% full. I think that's our second last point. Our last point is resource reservation, where protocols that reserve specific bandwidth for a particular application follow before data transmission begins. The telemedicine application uses the resource reservation protocol to guarantee a specific amount of bandwidth for remote surgery session, ensuring reliability and low latency. That's all we have from quality of service. Now this next question is about network security, and it's going to be answered by my friend here, Jonan, who is going to take us through our next session. Thank you very much. For any questions you have, I suggest that you leave them in the comment below. And also, we have agreed to make another video about IPv4 in detail and IPv4, IPv6 in detail. Thank you very much. Have a nice time.
My name is Jonan Kwizuka, doing bachelor's in information and technology, Team University, Kampala, Uganda. I'm going to take you through the next part of our presentation. I have a question. It says, describe the common security control concepts that protect enterprise network, and for each control, state its primary function and drawback. We are going to look at security control and see the meaning. Enterprise network security relies on a multi-layered approach, often referred as defense in depth, using various security controls to protect confidentiality, integrity, and availability of data and systems. No single control is foolproof, so they are combined to ensure that if one layer fails, others are there to prevent a breach. Have examples of security control concepts with their functions and drawbacks. Have firewall, which acts as a gatekeeper. Firewall acts as filtering incoming and outgoing network traffic based on predefined security rules to block unauthorized access and malicious activity. For example, of drawback, only blocks threats it is programmed to recognize. May struggle with advanced new (zero-day) or encrypted attacks and can create performance bottlenecks if inspecting traffic deeply. Continuation of the firewall. Intrusion detection or prevention system (IDs/IP). Yes. Monitors network traffic for suspicious activity or known attack patterns, generating alert IDs or automatically blocking identified threats in real time IPs. Yes. An example of drawback: often rely on a database of known attack signatures and may fail to detect novel attack methods (zero-day exploit). They can also generate alert fatigue for administrators. Access control limits access to network resources, data, and systems to only authorized users and devices through authentication and authorization mechanism. For example, strong password, MFA, role-based access. An example of drawback: are complex to manage in large dynamic environments. Misconfiguration can hinder normal business operations or leave vulnerabilities and insider threat with authorized access. It can still pose risks. Virtual private network, or what we can call VPN. It creates a secure encrypted tunnel for remote user to access the enterprise network, protecting the confidentiality and integrity of data transmitted over the internet. An example of drawback: performance can be impacted by encryption overhead. VPN, or what we can call virtual private network concentrators, can become a single point of failure or a bottleneck. An endpoint connecting via virtual private network can introduce vulnerabilities if not properly secured themselves. Encryption scrambles sensitive data during storage and transmission, making it unreadable to authorized parties if intercepted. An example of drawback: can create a blind spot in other security defenses like firewalls that cannot inspect the encrypted content. Also, managing encryption keys can be complex. Network segments. Looking at network segments, divide the network into smaller, isolated segments. For example, using VLAN or internal firewalls. Limit the lateral movement of attack or malware within the network. Another example of drawback: it can be costly and complex to design and implement correctly in a large organization, and managing policies across many segments, which requires significant administrative overhead. Antivirus, anti-malware software scans and detects and removes malicious software like viruses, trojans, and ransomware from individual device (endpoint). More example of drawback: primarily effective against known malware signatures, may not detect new or highly sophisticated malware (polymorphic or zero-day threats), which requires constant updates to remain effective. Here, security awareness training, which you are going to look at. Security awareness training, it educates employees on security policies and best practices, such as identifying phishing emails and using strong password to reduce the risks of human error. Example of a drawback: effectiveness depends heavily on users' adherence and ongoing training. It cannot entirely eliminate the risks of human error and does not stop automated technical attacks. We are going to look at question 4, which talks employees reports or slow access to a cloud service during business hours. Here it says outline a minimal troubleshooting checklist to perform in order to resolve the issue. Let's look at it. There is a cloud service diagram which shows that what we are going to talk about below. First and foremost, we need to know what is a cloud service. A cloud service is an IT resource or application provided over the internet by a third-party vendor. Instead of running software locally on physical hardware you own and manage, you access this service on demand from a remote provider's data centers, typically through a web browser or a dedicated application. The core principle is access on demand rather than ownership. Let's look at our checklist and we'll see what's below, and we understand what a cloud troubleshooting means. Here we can define a cloud troubleshooting as the process of identifying and fixing problems that occur in a cloud computing environments. It helps business ensure their applications and service run smoothly in the cloud. Cloud troubleshooting involves several steps, as we are going to look at them below. Identifying problems. The first step is recognizing that there is an issue. This may include slow performance, errors, or service outages. Gathering information as the third troubleshooting on our list. Once a problem is identified, data must be collected to understand the issue better. This can include logs, system alert, and user feedback. Fourth troubleshooting on our checklist, it is analyzing data. After gathering information, the next step is to analyze data, and this may help to pinpoint the cause of the problem. As a continuation on cloud troubleshooting, implementing solutions. Once the cause is identified, solutions can be applied. This may involve reconfiguring settings, updating software, or restoring the backups. Testing and monitoring. After implementing a solution, it's essential to test if the issue is resolved. Ongoing monitoring helps ensure that the problem does not return. Continuation. Solutions on drawbacks. Use monitoring tools to track response time and identify bottlenecks. Check network latency, server load, and database performance to pinpoint the issue. Another solution, check resource utilization, including central processing unit, what you can call CPU in our bracket, memory and storage. Scale resources up during peak times to ensure optimal performance. In other words, on our troubleshooting, we have to make sure that the resource utilization, including the CPU, we check the memory and the storage, get resources up during peak time to ensure optimal minimal performance. We have to make sure that it is performing or functioning clearly. As a solution, we can look at scale resources horizontally by adding more servers or vertically by upgrading existing servers. We have to, first and foremost, we will have to upgrade the existing servers to make sure that they are performing clearly. Use auto scaling to automatically adjust resource based on demand. As a solution, use profiling tools to identify and optimize performance bottlenecks in your code. Consider coaching frequently access data to improve the performance. Review the performance of the third-party service and consider alternative. If necessary, use service level agreements in bracket what we have to ensure third-party service meet your performance. Use a CDN, coach, and deliver static content closer to users. This will help reducing latency and improving load time. Thank you. For more explanation or for more understanding, you can visit us on our YouTube channel. We shall put more explanation on our cloud service. Thank you so much. We meet.